So 11.1 is Introduction to Sequences. So a sequence is just an ordered set of numbers. So a sequence that you guys know is like 1, 3, 5, 7, 9, 11. These are all the odd numbers. You could have like 1, 2, 4, 8, 16, keep doubling. An infinite sequence is one that goes on forever. A finite sequence is one that stops. So sometimes it's convenient to write sequences with subscripts starting with 0. We did this a lot in science classes. So if you've taken physics before, a lot of times they'll talk about initial velocity, and they'll call that v sub 0. And the reason they do that is because they want you to know that that starts at time 0, so at 0 seconds. But in our math classes, we're going to use our first subscript, so our initial one, as 1. So that way we can talk about the first term, second term, third term, and so on. So in this class, you'll just assume that the first subscript is 1. All right, so number 1, find the first 4 terms of the sequences. So if I have a sub n equals 2n minus 1. So if I want to find the first term, I write that as a sub 1. So I say sub for subscript. So what do you think I'm going to do with a 1?
Plug it in for n.
Yeah, just plug it in for n. It's just like functions. I mean, if I had f of x equals x plus 5, if I wanted to find f of 1, I plug in 1, right? It's just like a function. Okay, so I get 2 times 1 minus 1. So it's 2 minus 1, which is 1. So that's the first term of the sequence. All right, we need to find the second term, the third term, and the fourth term. So my second term, I just plug in 2 for n. So I get 4 minus 1, which is 3. The third term, 2 times 3 minus 1, so 6 minus 1, which is 5. And the last one, 2 times 4 minus 1, 8 minus 1 is 7. So that's just the odd numbers, 1, 3, 5, 7, 7. Okay, the next one's a little bit harder, so how about you guys try part B, see if you can get it. Did anybody get all 4 numbers? What was A1? No, I heard 1, I heard negative 2. So let's see. So I have 3 plus 2 times 1 times negative 1 to the 1. So do your exponents first, remember order of operations. So I have negative 1 to the first is negative 1, times 1 times 2 is negative 2. And then I have 3 minus 2. So I think you just forgot the 3 part. So you should get 1. Okay, A2 is going to be 3 plus 2 times 2 times negative 1 to the second. So negative 1 squared is 1 now. So 1 times 2 is 4, plus 3 is 7. A3, I do 3 plus 2 times 3 times negative 1 to the third. So when I have negative 1 to the third, that's negative 1 again. So negative 1 times 3 times 2 is negative 6. So 3 minus 6 is negative 3. And A4 is 3 plus 2 times 4 times negative 1 to the fourth. So negative 1 to the fourth is 1 again, times 2 times 4 is 8, plus 3 is 11. Okay, did anybody get all 4? Good. That's a lot of you. All right, so what about example number 2? So find the 20th term of the sequence. Do I need to find all 19 terms before it? No. If I'm finding the 20th term, you just plug in 20. So I get 60 plus 5, so 65. Okay, so that's what we call an explicit formula. It's a formula where you can just immediately find the value of n. So like, well, the nth term. So if I wanted to find the 100th term, I just plug in 100. All right. There are formulas, though, that are defined recursively. So when I say that, a recursive sequence is a sequence in which the nth term is based on the one directly before it. So in order to find the 20th term, I would need to find all 19 terms before it to get to it. Yeah, yikes. All right, so we're going to write the first 5 terms of this recursive sequence. So I'm given that my first term is 1. So you're usually given like an initial term, usually the first one, but sometimes you could start at the 10th term. Okay, so A1 is 1. Now A sub n is equal to 2 plus 5 times A sub n minus 1. Okay, think about what those different things mean. Okay, a sub n, what does that represent? The nth term, right? Okay, so if that's the n minus 1, well, that just means that's the term directly before it. Okay, so we were already given the first term, so let's go ahead and start with the second term. So let's find a2. Okay, so a2 is 2 plus 5 times a sub, what subscript do I need? 1. Okay, think about why that is. If I'm plugging in n is 2, see in my formula n is 2. In the second part, I'm going to have 2 minus 1, so it's a sub 1. So this means my second term, a sub 2, is 2 plus 5 times a1 was 1, which is 2 plus 5, which is 7. Okay, so let's find a3. a3 is going to be 2 plus 5 times a sub 2. Because if I'm plugging 3 in for the n, see where I'm pointing? So 3 is n, so n minus 1 is 1 less than that, it's 2. Okay, well, that means it's 2 plus 5 times, now a sub 2 isn't necessarily 2. Like a lot of people, that's the mistake they make on their test. They just put 2 there. A sub 2 means the second term. So what was our second term? 7. So you're plugging in 7. So you have 2 plus 35, so I get 37. All right, and then a sub 4. So I have 2 plus 5 times a sub 3. So it's 2 plus 5 times the third term was 37. So I get 2 plus 185. Is that right? 185? So I get 187. Okay, making sense? All right, next page. Let's see. Oh, what a stud. Fibonacci. Okay, so this says the Fibonacci sequence is defined recursively by a sub 0 equals 1, a1 equals 1, and ak equals ak minus 1, or ak minus 2 plus ak minus 1. All right, so this one's a little different. Does it bother you that I use k's? Same thing, right? You can use whatever letter you want. So you won't always see n's. Okay, so I gave you that a sub 0 is 1. a1 is also 1. Okay, so I know the 0th term and the first term, kind of weird the way you say those. How do I find the second term?
1 plus 1.
Yeah, you're plugging in. See if you plug in 2 for k. This one's 2 minus 2, so that's going to be 0. This one's 2 minus 1, so that's going to be 1. Those are the subscripts. A sub 2 equals a sub 0 plus a sub 1. Well, a sub 0 was 1 and a sub 1 was 1. So I get 1 plus 1, which is 2. So Forrest was exactly right. Okay, a sub 3. So think if I'm plugging 3 in for k, then the next one is going to be what? A sub 1 plus a sub 2. Do you guys see where I'm getting this? A lot of you are just staring off into space, I think. Do you see what I'm saying? So if 3 is equal to k, 3 minus 2 is 1, 3 minus 1 is 2. So that's where those are coming from. So a1 was 1, a2 was 2, so I get 3. Do we think a4 is going to be 4? No? Can you guys tell what a4 is going to be? Yep, so it's the sum of the two things directly before it. So maybe write yourself that note. So this one's the kth term. The other two are the two directly before it. So subtracting 1 and then subtracting 1 more. Okay, so when I do that, a2 is 2, a3 is 3. Add them together, I get 5. All right, this is going to be kind of annoying to do for 8 terms. So let's think about what we have. So my sequence, I started with 1, then I had 1, Then I went to 2, 3, 5. What's the next one? 8. Jack, how'd you get 8? You added what together? Yeah, you just add the 2 directly before it. Do you guys see the pattern? So when I add 1 and 1, that's how I get the 2. When I add 1 and 2, that's how I get the 3. When I add 2 and 3, that's how I get the 5. Add 3 and 5, that's how I get 8. So what's the next one? 13, 21, 34, 55. You can go on forever. All right, so we talked a little bit about the golden ratio, how it's found a lot in nature. I mean, it's found in like weird things too. Like apparently the more and more bees you collect and count, the number of, I think it's male bees divided by the number of female bees gets closer and closer to this golden ratio. The golden ratio, by the way, is like 1 plus the square root of 5 divided by 2, which is approximately 1.618. And it goes on forever. All right, so the Fibonacci sequence also has the golden ratio in it. It's very strange. So if I look at the millionth term and I divide by the 1 directly before it, so 999,999 term, it's going to be very, very close to the golden ratio, so to that number. Okay, so the further out you go, the even closer it is. It's crazy. All right. Okay, so let's talk about n factorial. Okay, it's n with a little exclamation point. That's what a factorial is, that little exclamation point. So now we run out of symbols, so we have to like use symbols from the keyboard, I guess. So n factorial, all it is, I'll write an example. So if I have 5 factorial, it's all the numbers up to 5 multiplied together. So all the whole numbers. So I'd have 5 times 4 times 3 times 2 times 1. Okay, that would be 120. That's what 5 factorial is. So if I have n factorial, start with itself, n. What's the number directly before n? N minus 1, n minus another one, minus 2, n minus 3, and so on, right? All multiplied together, and then you get times 3 times 2 times 1, right? You go all the way down to 1. That's what n factorial is. Okay, so we talked about the debate before about 0 to the 0, because if it's 0 to some number, you'd think it'd be 0, but anything to the 0 power is supposed to be 1. So what is 0 to the 0? Same kind of thing with 0 factorial. There's a big debate as to what it should be, but 0 factorial, we actually say it's equal to 1. And your calculator will say that. It won't say error or anything.
Where do you do this on your calculator?
I don't know. We'll see. I'll teach you. All right, so 6 factorial. So let's do it by hand first. So I have 6 times 5 times 4 times 3 times 2 times 1. Okay, I just told you 5 factorial, so the first 5 multiplied together are 120. So times 6 gives 720. Okay, next one. So if I have 8 factorial over 5 factorial. Okay, the way you guys would probably write this is 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 all over 5 times 4 times 3 times 2 times 1. Okay, so basically like the numerator's all factored out kind of, and the denominator's kind of all factored out. Not really, I mean 4 can break into 2 and 2 and stuff, but you see what I'm saying? They're all like multiplied together. So you can reduce. So all those would cancel. So it would just be 8 times 7 times 6. Did anybody find that? 336. Thank you. Okay. So I don't want you to have to write all that out. I mean, what if you were doing 20 factorial divided by 19 factorial? I mean, you don't want to have to write all those out. So here's a shortcut. So look for your bigger number. So 8's bigger than 5. You're going to write everything until you get to the smaller number. So 5 was a smaller number. Then you write factorial. So basically it's going 5, 4, 3, 2, 1. On the bottom, write 5 factorial. All of those factors cancel, right? So isn't that easier to write that way? So you just get 336. All right, so I will let you try this on your calculator. So on your calculator, in order to find the factorial, so if I wanted to do 8 factorial, want you to plug in 8 into your calculator. Then you're going to hit the math button, which is on the far left. You're going to arrow over. So when you hit math, do you see at the top? So at the very top of your screen, it has all these different choices. You want to arrow over to PRB. That stands for probability. And then I think it's the 4th term, or the 4th one. Okay, hit enter. It will give you 8 factorial. Okay, and then you can divide by 5 factorial. All right, so try C, and I want to see if you guys get it right. So try C. Okay, what's an answer someone got? Yeah, Lillian? 2,520. Anybody get anything else? Y'all got that? Okay, so let's see what this is. Yeah. All right, so if I have 10 factorial, I'm going to write it out as 10 times 9 times 8 times 7 times 6 factorial, because I had that big 6 factorial in the bottom. Okay, 2 factorial was just 2 times 1. So that means 6, 5, 4, 3, 2, 1 cancel, so those are gone. And then 10 and 2 can reduce to 5, so let's do that. So I have 5 times 9 times 8 times 7. So what's 5 times 9 times 8 times 7? What was it? 5,040? Well, I don't think, is that what it is? It seems big. 2520? Is that it? Okay. Is that what it was? Seems big to me. Did you do 5 times 9 times 8 times 7? No. Do 5 times 9 times 8 times 7. See what you get. 2520, okay. All right, so how many of you got that right away when you used your calculator? Like, from the beginning? Only 3 or 4 of you? How many of you got something else? What happens is when you guys try to put this in, this is how you put it into your calculator. Okay. And what your calculator does is it does 10 factorial and it divides by 2 factorial, but then it takes that answer and it multiplies by 6 factorial. So how could you avoid that? Yeah, put parentheses on it. So if you're going to do this on your calculator, make sure you have parentheses. So if you don't show any work on your test, if I didn't see all of these steps up here, and you just do it wrong on your calculator, you miss all the points, right? You need to show some work. So I'm not going to try to figure out how you did it. All right, so part D, this one we can't use our calculator on. It has n in it. So we really got to think about it. So if I have n factorial and I have n minus 2 factorial, which number was bigger, n or n minus 2? N. So I'm going to start with n, and I'm going to keep going down until I get to n minus 2. So that means my first term is n. The one directly below it is n minus 1. The one directly less than that is n minus 2, right? Subtract 1 more. And then it goes on all the way to 1. On the bottom, I have n minus 2 all the way down to 1. So do you see what happens? So the n minus 2 factorials, those are gone. So it's always going to be equal to n times n minus 1, or n squared minus n. And you can check with numbers. Like you could find 10 factorial over 8 factorial. It would equal 10 squared minus 10. It would equal 90. So you can check. All right, next up. So write the first 4 terms of the sequence given by a sub n equals 2 to the n all over n factorial. So I'll give you guys a second to try this one on your own. So try this one. Okay, so on this one we have a sub n equals 2 to the n over n factorial. So if I find a1, it's 2 to the 1 over 1 factorial, which is 2 over 1. So I get 2 out. A sub 2 is 2 to the 2 over 2 factorial, which is 4 over 2 times 1. So 4 divided by 2 is 2. So do you think all of them are 2? No? What'd you guys get for A3? Yep, it is 4/3. Good. 2 to the 3 over 3 factorial is 8 over 3 factorial is 3 times 2 times 1, so 6. So it is 4 over 3. And what'd you get for A4? Yep, good. So you have 16, 2 to the 4th, over 4 times 3 times 2 times 1. Well, you already found 3 times 2 times 1. That was 6. So times 4 gives 24. Divide by 8 on the top and the bottom. So you do get 2/3. Good. Okay, I want to go ahead and start 11.2 today too. So let me stop this.